You must have seen a dry coconut, and the surface of this dry coconut is very hard. But when you break it, you find that the inner surface is very soft. Same thing is shown in this picture also. After breaking the coconut, you find a thin layer of dark brown color which is very hard, but just beneath that there is a soft layer which is in white color. So it consists of basically a hard case and a soft core. Similar thing happens in case of case hardening treatment, whether it is carburizing, carbonitriding, induction hardening or flame hardening. When you do such treatment and when you cut a section and you check it, then you find that there is a case at the surface which is hard, but the core is soft. So this case has got some depth, and this case depth is of two types. One is effective case depth and the other one is total case depth. Here effective case depth is very important because any designer who designs a part based on the application, he considers basically effective case depth. On this actually the part properties such as wear resistance, strength and fatigue strength, all these things are depending upon the effective case depth. In part 7 I have already described how to determine this effective case depth in case of carburizing and carbonitriding parts. But in this part 8, I am going to describe how to determine effective case depth in case of induction hardened or flame hardened parts. So without wasting your valuable time, I am going to start this video on how to determine effective case depth in case of induction hardened or flame hardened parts, but after a short break. Hello friends, welcome on my channel Jagdish Chaubey. This video is Metallurgical Quality Control Series 2 Part 8. I am going to describe about how to determine effective case depth in case of induction hardened or flame hardened parts. So let's go. So before I go in detail, let me go through the flashback. Prior to this, I have released 7 videos. Part 1, that was on Chaubey hardenability test. Part 2, it was on erection cupping test. Part 3, Chaubey impact test. Part 4, IED impact test. Part 5, inclusion rating of steel. Part 6 was austenitic size, grain size. Part 7 was effective case depth in case of carburizing and carbonitriding parts. So let's see what it contains. So I'll be covering same format, purpose, what is the purpose of doing this test, test equipment, what are the equipments used, then test methods and procedures, precautions, problems and their possible solution. So first thing is purpose. What is the purpose of doing this test? So the purpose of determining effective case depth in induction hardening or flame hardened parts of steel is to verify and confirm ECD as specified by the designer depending upon the part application. Whenever a part is designed for case hardening purpose, whether it is flame hardening or induction hardening, the designer designs this part based on the effective case depth which is achieved during this treatment. And this particular ECD is very important to achieve the material properties as per the part application, whether it is high wear resistance, fatigue resistance or even strength also. So this is the purpose of doing this test. Okay, go further. So equipments. So for this there is a sample preparation stage is there. In sample preparation we use all these instruments which has been explained earlier in MQC-1 part 7 if you want to know the detail about these things. And Rockwell hardness testing here I have used. This also if you want to go through in detail, you can refer MQC-1 part 3. So all these instruments are being used for testing of this effective case depth. Procedures. If you want to go in detail, please go through this BIS Indian Standard 6416/1988. If you refer this, you will know all about this. Okay. But let me explain the same thing in sample preparation, cutting, belt grinding, emery paper grinding, mounting, polishing, then etching, and microsample is ready for your hardness check. In case of checking the hardness in VPN, you have to etch it also so that you get the fine. Wherever the accuracy is required, you have to go for VPN. But for general purpose, we are checking through Rockwell hardness testing, where etching is not essential. You may etch it, but it's not essential. You have to go only up to the polishing surface, because you can see you have to check the hardness from surface to core, in which case you can check easily on HRC without etching it. Same procedure again. Hardness test, when the sample is prepared, how to check the hardness. There is two types, Rockwell hardness test and Vickers hardness test. For Rockwell, you have to refer again MQC-1, my earlier series, part 3. And for Vickers hardness, you have to refer the previous part 7 of this particular series. Here you see this is only polished surface, and you can just see the glance of this case depth. And this is a fine surface which is polished and edged also, and this is used for checking effective case depth in case of VPN. In this, if you can see it, let me enlarge it for you. See, in this you are seeing the top surface is case here to here, all black. In between there is a transition zone. So this is case core transition. You see this, and below this is a conform line, this black line. Below this is all core. So this consists of case, transition, and then core in case of when you are polishing it and etching it for VPN. Okay. So how to check this effective case depth? In this slide, see, in case of induction hardening, the effective case depth depends upon the carbon content of the material. So depending upon percentage carbon, you have to check effective case depth depending upon the hardness value achieved. So in this, if you see, the first one is, if the carbon is 0.28 to 0.32, HV should be 350. You have to check the effective case depth at HV 350, or if you want to check in HRC, you can check at 35 HRC. In case of HRA, you have to check at 68. For 0.33 to 0.42, you have to check at 400 VPN has to be considered for checking the case depth. Then in case of HRC, it will be 40 HRC. In case of HRA, it is 70 HRA. For 0.43 to 0.52 carbon, 450 is the HV value, 45 is the HRC, and 73 is the HRA value. And if the carbon content is more than 0.53, then you have to check at HV 500 and HRC 50, HRA 76. This checking in different scale, particularly HRC and HRA, is based on particularly on the case depth of the material. If the case depth is very thin, it's not much, then you have to check basically HRA. Otherwise, if you check the same thing on HRC, it will puncture the case. So it will not be the effective case depth. So in case of lower case depth, wherever lower case depth is there, that you have to check 68, 70, 73, 76 HRA like this. But if the case depth is quite good, generally in induction hardening, depending upon the frequency of the induction furnace, whether it is low or medium, case depth varies. So for higher case depth, again, you can check on HRC also, depending upon carbon content, 35, 40, 45 and 50. So for induction hardened jobs, the effective hardness will be at different scales as shown in this particular table. As far as hardness plot is concerned, this is the plot which is y-axis, it is hardness. It can be HRC or it can be HV also. And the x-axis is basically distance from the surface, which is millimeter. And you see the profile of this curve in induction hardening. It is like this. You see, it goes up to some extent and then it drops suddenly. and then goes to the core and then remains constant. This is one of the major difference between a case hardening curve of carbonizing or carbonitriding or induction hardening. In case of carbonizing, it will go like this, slightly flat here, and then it goes like this. So, whenever you see such type of curve, you can immediately say that it is a curve for induction hardening. So, depending upon carbon content and this hardness referred here, you can calculate the case depth in millimeter, whatever parts you have heat treated. See, this is how this thing has been done. If you want to check in detail, again you have to go through the IS procedure 6416 1988. Go through that. It describes very in detail. Okay. So let me go ahead. What are the precautions to be taken? All necessary precautions to be taken in sample preparation. For this you have to refer MQC-1 part 7. I am not going to repeat all these things. Was already there. For hardness checking in VPN, indentation must be made as directed in MQC-2 part 7 slide 9. This in slide 9 in the previous part 7. You can know that how this VPN has to be checked, hardness has to be checked. Then ECD based on hardness must be determined as per chart given in slide number 8 as standard practice, otherwise as per the customer requirement. So in case of determination of ECD based on the hardness, you have to follow slide 8, okay, just the previous slide, wherein I have given a chart depending upon the carbon content. You have to select a particular VPN scale or HR scale, and then you have to check the effective case depth. Otherwise, the best thing is whatever the customer has specified, whether he is specified in HV or he has specified in HRC, you have to check accordingly. Rockwell hardness tester or micro hardness tester or Vickers hardness tester must be calibrated as per the frequency of the use. This is also one of the important precautions that you have to take, that all these instruments, hardness testing equipment, whether it is a Rockwell or a micro hardness tester or a Vickers hardness tester, it has to be calibrated at least once in a year depending upon the frequency. If the frequency of use is too much, then it should be half yearly basis, but it has to be calibrated. Okay. Then comes problems and solution. Problems: hardness indents are not clear. Take necessary precaution in sample preparation. This also I have explained earlier. You have to take, the sample should not be burned while cutting it. Etching should not be over. So all these precautions have to be taken, and polishing has to be quite good. This I have already described earlier also. So you have to go through that. Then indents are not perfect square when measured in VPN. Whenever you are checking in VPN, you are not finding the correct or square indent. So for this again, check the distance from the surface end or distance between indents D1, D2, D3 or S. S is a distance of the centers between two indents as mentioned in slide 7 of this. So this again you have to refer to the previous slide. Go to that side, it explains everything. Okay. For Rockwell, you have to refer again part 3 of MQC-1. So all these things are actually a repetition, so I am not going to tell you in detail because it will take a long time. Okay. So these are the basically problems and their possible solution. So as far as this particular part is concerned, part 8, this video ends here. I think I have explained much of the things. Started with your case depth requirement. What are the types of case depth? Okay. Then effective case depth, total case depth. Then what are the equipments used for checking this particular ECD? And after that, relation between carbon content and VPN on which you have to check the case depth. So that table is there. It's a very important table. You have to go through that. And then lastly, it was precautions, whatever precautions to be taken, and further problems and their solutions. So with this, I finish this chapter here. And if you like this video, kindly like it. You share also with your friend or WhatsApp circle. And if you are new to my channel, then kindly subscribe it also. So with this, I end this program here only. But before I end, let me go through the last slide. See, in this Metallurgical Quality Control Series 2, I have covered almost these videos. Okay. 7. Jomny end quest test, erection cupping test, Chaubey impact test, IZ impact test, inclusion rating in steel, then austerity grain size steel, effective case depth in carbonizing or carbonitriding, effective case depth in case of induction hardening or flame hardening. So all these things I have covered. All these tests are very important tests, and they are being day and night. This is being used by any metallurgical lab or steel plant or heat treatment plant. So these are very important. So I think you must go through all these. If you have not seen this video, please go through it again on my channel Jagdish Chaubey. Okay. So I end up this program here only. I must thank you for your patience of listening this, and thanks for watching my program, and also sharing, subscribing, liking my program. So thank you very much.